Hello viewers. Welcome to the YouTube channel. In this video we will discuss Class 11 or First PUC Physics Chapter 2, that is Motion in a Straight Line. Class 2. From Basic to Advanced Level, for Board, JEE, KCET, and NEET. Do support watch till end, don't forget to share, subscribe the channel. First chapter, that is Units and Measurement. That video link is given in description, don't miss it. Let's start. Instantaneous velocity. Velocity is defined as the limit of average velocity as the time interval becomes infinitesimally small. That is, v is equal to limit delta t tends to 0, delta x by delta t is equal to dx by dt. Instantaneous velocity is also called velocity. In position time graph, instantaneous velocity at a point is the slope to the tangent drawn to the curve at that point. Instantaneous speed or speed is the magnitude of velocity. Next, uniform velocity. If equal changes of displacement take place in equal intervals of time is called uniform velocity. Note: when a body moves with uniform velocity, neither the magnitude nor the direction of the velocity changes. Difference between speed and velocity. Speed, velocity. Speed. It is defined as the ratio of the path length to the time taken. Velocity. It is defined as the ratio of displacement to the time taken. Speed is a scalar quantity. Velocity is a vector quantity. Speed is always positive. Velocity may be positive, negative or zero. Next, acceleration. It is defined as rate change of velocity of a particle. Acceleration is equal to change in velocity by time taken. That is, a is equal to v minus v naught by t. Acceleration is a vector quantity. SI unit is meter per second and dimension is m0L1t-2. Since velocity is a quantity having both magnitude and direction, acceleration may result from a change in magnitude or a change in direction or changes in both. Acceleration can be positive, negative or zero. The negative acceleration is called retardation or deceleration. Average acceleration. It is defined as the total change in velocity divided by the total time taken. A bar is equal to v2 minus v1 by t2 minus t1 is equal to delta v by delta t. Next, instantaneous acceleration. It is defined as the limit of the average acceleration as the time interval delta t becomes infinitesimally small. A is equal to limit delta t tends to 0, delta v by delta t. That is equal to delta v by delta t. Next, uniform acceleration. If the velocity of a body changes by equal amount in equal intervals of time, however small these time intervals may be, is called uniform acceleration. Non-uniform acceleration. If the velocity of a body changes by unequal amount in equal intervals of time, is called uniform acceleration. Next, graphical representation of motion. Graph. A diagrammatical representation of variation of one quantity with respect to another quantity is called a graph. Next, position time graph. It is a graph obtained by plotting instantaneous positions of a particle versus time. Next, 1. Positive acceleration. When distance covered by a moving object goes on increasing with time, the object is said to be positive acceleration. 2. Negative acceleration. when distance covered by a moving object goes on decreasing with time, the object is said to be negative acceleration. 3. Zero acceleration. When the moving object covers equal distance in equal time. Here slope v is equal to 0. Next, let's see position time graph. 1. Position time graph gives instantaneous value of displacement at any instant. 2. The slope of tangent drawn to the graph at any instant of time gives the instantaneous velocity at that instant. 3. The ST graph cannot make sharp turns. Let's see some different cases of position time graph. 1. At rest. In case of at rest, the velocity of the object does not changes with time. Therefore, slope v is equal to 0. 2. Uniform motion. In case of uniform motion, having zero initial position, then graph shows a straight line. Therefore slope v is constant. And a is equal to 0. Next. Uniformly accelerated motion with u is equal to 0, s is equal to 0, at t is equal to 0. Therefore, the slope of ST graph at t is equal to 0 should be 0. Next. Uniformly accelerated motion with u not equal to 0, but s is equal to 0, at t is equal to 0. Therefore, the slope of ST graph gradually goes on increasing. For uniformly retarded motion, the theta is decreasing, so velocity is decreasing. And a is negative. Next, let's see velocity time graph. 1. Velocity time graph gives the instantaneous value of velocity at any instant. 2. The slope of tangent drawn on graph gives instantaneous acceleration. 3. Area under VT graph with time axis gives the value of displacement covered in given time. 4. The VT curve cannot take sharp turns. Let's see some VT graph in different case with features of graph. 1. Uniform motion or object at rest. In case of at rest, the velocity of the object does not changes with time. Therefore, velocity v is constant. Theta is equal to 0 degree. Slope is equal to 0. Next. Uniformly accelerated motion with u is equal to 0, s is equal to 0, at t is equal to 0. In case of uniform motion, having zero initial velocity, then graph shows a straight line. Therefore, slope is constant. That is v is equal to 0 at t is equal to 0. Uniformly accelerated motion with u not equal to 0, but s is equal to 0 at t is equal to 0. In this case, the object have some initial velocity, then the VT graph is straight line starting from u. Here, positive constant acceleration because theta is constant and theta is lesser than 90 degree, but the initial velocity of the particle is positive. Next, uniformly decelerated motion. Here, the velocity of object decreases linearly with time. If the object is moving with negative acceleration, have some positive velocity, then the VT graph is a straight line having negative slope. Next, non-uniformly accelerated motion. In case of non-uniformly accelerated motion, the velocity of an object goes on increasing exponentially or non-linearly. If an object is moving with increasing acceleration, having zero initial velocity, therefore the VT graph gives instantaneous acceleration. Next, non-uniformly decelerating motion. If theta s decreasing, then acceleration also decreasing. Next, let's see kinematic equation for uniformly accelerated motion. For uniformly accelerated motion, we can derive some simple equations that relate displacement, s, time taken, t, initial velocity v0, final velocity, v, and acceleration, a. These equations are called kinematic equations for uniformly accelerated motion. The equations are 1. V is equal to v0 plus at. 2. X is equal to v0 t plus half a t square. 3. V square is equal to v0 square plus 2ax. Let's derive the equation of motion one by one using graphical method. 1. V is equal to v0 plus at. Consider a particle in motion with initial velocity v0 and constant acceleration a. Let be the final velocity of the body at time. From the figure, slope is equal to bc, by ac this can be written as bd minus cd by ac. But here, cd is equal to oa and ac is equal to od. Therefore slope becomes slope is equal to bd minus oa by od. bd, that is v, oa, that is v0, and od is t. Therefore slope is equal to v minus v0 by t. But slope of vt graph gives the acceleration. The above equation write as a is equal to v minus v0 by t. Take t at left, we get at is equal to v minus v0. Also move v0 here, we get v is equal to v0 plus at. 2. X is equal to v0 t plus half a t square. Consider a particle in motion with initial velocity v0 and constant acceleration a. Let be the final velocity of the body at time. From graph, therefore, displacement is equal to area under vt graph. That is, x is equal to area of trapezium OABD. That is, x is equal to 1 by 2 into bracket OA plus BD into AC. On substituting values, we get x is equal to 1 by 2 v0 plus v into t. But v is equal to v0 plus at. On substituting above value in v, x is equal to 1 by 2 into bracket v0 plus at into t. On simplifying, x is equal to 1 by 2 into bracket to v0 plus at into t. On solving, we get x is equal to 1 by 2 into 2v0 into t plus 1 by 2 into at into t. Cancel this too. Finally we get x is equal to v0 t plus 1 by 2 at square. 3. V square is equal to v0 square plus 2a x. Consider a particle in motion with initial velocity v0 and constant acceleration a. Let be the final velocity of the body at time. From graph, therefore, displacement is equal to area under vt graph. That is, x is equal to area of trapezium OABD. X is equal to 1 by 2 into bracket OA plus BD into AC. On substituting values, we get x is equal to 1 by 2 v0 plus v into t. But v is equal to v0 plus at and t is equal to v minus v0 by a. On substituting above value in v and t, x is equal to half v0 plus v into v minus v0 by a. On taking LCM, x is equal to half v square minus v naught square by a. Take 2a this side. We get 2ax is equal to v square minus v naught square. Now take v naught square this side. Finally we get v square is equal to v naught square plus 2ax. In the next class we discuss problems. So don't forget to subscribe the channel for more.